Welcome to the future.
Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. All right, well, let's start with the low-hanging fruit, okay? So this rewire push button to pull up, not a pull down. So I'm on the main PCB schematic. Here's the rotary encoder, and here's the push button. And let's zoom in here a little bit. Hold on for a second. I think I can turn these dots off. Oh, there we go. That looks better. And yeah, I don't know what's going on here. So this is going to the ESP32, right? You can kind of see it right here, the input. And I put that pull-up resistor. I don't know what I was thinking right here. I must have been smoking crack that day or something. That's that's not good. So yeah, let's go ahead and fix this real quick. So I think what I'll do, and this is probably not going to be the cleanest look, but I don't want to spend a lot of time. Let's drop this guy down, and we'll just tie him in right there. I kind of move these around a little bit. All right. There. All right. Fixed. So, yeah, that wasn't too bad. Like I said, I could probably have put this somewhere else, but it's okay. Alrighty, so that's, where is it? Oh, there we go. I'll go ahead and just scratch this guy off the list. I'm going to look at this real quick so we can go ahead and scratch it. I don't think this is a problem, these channels 10 and 20 on the ADC, but that's on the main board. I'll click on the ADC here. Channels 10 and 20. Let's see. Oops. So here's channel 20. Oh, what's wrong with this? Yeah, snapping's not working. Maybe because I turned the grid off. Anyway, yeah, so here's channel 20. All right, number 35 right here. And here's channel 19, which is the differential for 20. That's what that stands for, cold junction differential. And then cold junction. And I do believe it's wired correctly. It just dies to ground right here. Everything is grounded. Well, yeah, let me pull up the data sheet for the ADC. Okay, so here's the data sheet for our LTC-2984 super chip. The multi-sensor high accuracy digital temperature measurement system with EEPROM. All right. Let's see, diode measurements. We want just okay, yeah, so here's our little schematic for does this thing zoom? No, it doesn't zoom. Okay, so we've got channel, right? There's a channel assignment, so this would be 20. It's going through the diode, and then it's grounded, and it's going to channel D-1. I forget what D stands for. Anyway, that's the channel number, right? So this would be 19. I do believe. Yeah, so we've got, here's channel D, channel 20. It's going down here, it's going through the diode, past ground, up here, right there. Yeah, I've got the common pin tied. I probably could have put him down to ground right here. That would have been okay. Yeah, oops. That looks okay. Yeah, I'm not sure. Let's go look at channel 10 here real quick. I think, yeah, it's the same. So here's channel 10, it's going through the diode, here's the ground. Yeah, this one doesn't even have that common pin tied to it, so it's easier to look at than the, because it looks like identical to the schematic, right? So, yeah, I don't know what that node is, but like I said, everything's tested out pretty good, so I would be really surprised if it didn't work. So, good. Yeah, that was easy. Okay, so since we're looking at the ADC, we might as well knock these guys out. And by the way, if you're wondering why I didn't start resizing the PCB here, is if you remember the flow for these schematics, for doing electronic design, you do the schematic, then you import the changes of the schematic into the PCB layout, right? And so I want to make sure we got all our schematic fixes in first before we start, hacking away at the PCB. So that's what I'm doing, is I'm just going through here and fixing the schematic. Okay, so we're gonna get to D101, D102. Okay, put him away. And oh, wow, same guy. Let's see, we need to change his footprint. Yeah. So my guess, oops. Okay, let's go see what his pattern is. Properties. Attached pattern. Okay, it's just a standard 0805 diode pattern. Okay, so we need to make it I'm going to keep the same diode symbol, but we're going to make it a custom NPN transistor pattern. All right. Okay, so here's my component. And I don't think I made a custom pattern for him. No, I'm going to have to make a new one. All right. Let's see here. We want to search. We want to go find in all the libraries. Whoa. There we go. They look identical. So we're just going to open this component, and I'm going to save it. I want to copy it to another library. Users, no. There we go, TC components. All right, so let's go back to our component library. If I can remember how to get there. There we go. Okay, where is he? Probably at the very bottom. There he is. So, I need to figure out a name for this guy. The only place I actually saw it being called a diode, a transistor was, well, I don't remember, to be honest with you. It's so you can see the symbol, but they actually used a transistor. Wow. I don't remember. Anyway, I'll be right back. Okay, well, I pulled up this document. This is a little demo circuit from Linear, and he actually put the NPN transistor symbol in there. So I guess I'll do the same thing. I'll just replace that diode. That makes more sense anyway, instead of making some custom component. Yeah, so yeah, let's just do that. That'll be simple. So I'm gonna just delete this guy. We don't need him. And let's see, NPN. Well, I have an NPN component right there. Okay, well, it's a good thing I started looking at this. So I was looking at my BOM here, and yeah, Q1, Q2. Oh, we got two Q2s, Q8. But they're all 3904s. And so here's Q2. Yeah, and I don't think that's right. I thought I used a 3904, and I was looking at DigiKey. Let me see if I can find it here. Yeah. So Q10, Q11, these numbers, these reference designators are not up to date. Used for diodes D1, D2. I think I'm just using them for everything now. So I need to update that. And we're using the MMBT 3904. So from On Semiconductor. All right. So I'll just go ahead and update that. I'll be back. I won't record. So I was updating the schematic, and one of the things I wanted to show you, this is why I like using DigiKey. It's the small things that help. So here's the part number, and of course it's a hyperlink. It'll take you to the part, and copying, pasting hyperlinks can be troublesome, as you probably know. And they realize this, so someone put this nice little button there, so you can just click on it, do a Control-C, and you can paste it right into your schematic. Isn't that nice? I'm telling you, I just love these guys. So, paste. There we go. It's still on semiconductor, so very good. And I'll have to update that in the components, but I just wanted to show you that. Okay, so I went ahead and updated our NPN transistors. We'll just use 3904s throughout the whole thing, except for the MOSFETs are. So let's see, we need to go to the schematic and see if I can remember how to do this. Let's see, right click, we need to replace part with this guy. All right. Yeah, there we go. And we'll just do that with all of them. Let's see, replace part. Oh, where'd it go? Okay, so I went ahead and updated all these transistors. And by the way, if you're wondering, I did use these 3904s in the prototype, because I remember buying them. That's why I was surprised that it had the old number still in it. I must have just forgot to update the schematic. Anyway, yeah, so we need to go to our ADC, and now this one's going to make a little bit of a difference. So now I'm going to replace this part. Yep, that confused it. Let's see. We'll go fix it here. All right. Very good. So, there. Whoop. I don't know if that's wired up correctly. Well, let's go. I just wanted to make it look neat. Let's go find the schematic real quick. Here we go. So we need to come out of the channel and then go into the base and into the drain. Sorry, my bad. I meant the collector. When I said drain, I was like, that doesn't sound right. Anyway, so let's see if we can fix this guy real quick. So I'll double check. Come out of the channel into the collector and the base. And then the emitter just ties to ground, right? All right. So let's see, we'll disconnect this guy. Oops. Well, dang nabbit, how come I can't delete this wire? Oh. Whoa. I just want to disconnect it. Where is it? I know you can disconnect it. I'll be back. Okay, I found it. It's actually delete line. I'll show you on the other one. Oh, actually, I can show you on this one, can't I? Yeah, it's delete line. I think in the schematic, in the PCB layout, it's disconnect, but okay. So, let's flip this guy around. Let's see. All right. And let's see, we want to flip them. Yeah, does that make sense? I think that makes sense. All right, and let's see, we need a ground. Man, I need to fix my grid or something. It's not snapping into place properly. And sometimes this recording software messes with programs. So I'll look at it here in a minute. Oh, we also need to tie this guy. Okay, I think that's right. And then we need to come out of this guy and go to here. And then from here, we need to go to right there. Oh, that didn't work. So from here to there we go. All right, let's clean them up a little bit. Whoop, there we go. Well, I'm sure everyone's probably wondering why I stuck a second ground in there, and to be honest with you, I can't answer that question. I think I was just following this thing a little too closely. So let's just do a sanity check. Okay, so we're coming out of our channel, our designated channel. All right, we're coming down, we're going into the base and the collector. So base and collector, and then we're coming out of the emitter, which is going to ground. But since we're using a differential measurement, oh, maybe this is why I was thinking it doesn't do the differential measurement on this, because he doesn't have it drawn in here. Oh, that's interesting. I'll have to look into that. Okay, so I pulled up the the code for the the ADC, and here's channel 10 right here, and so I am doing differential measurement on those off-chip diodes, right? And actually, I soldered an NPN transistor in there. I think I did a video on that. I'm pretty sure I did, because the diodes I had bought, didn't work real good, and I was just following along with that guy's example, and those transistors worked much better for measuring temperature. And as you saw it, they work pretty good. So so I am doing differential measurement, and the reason why, I think this is why I had that note in there. Okay, so here's the universal input schematic, right? And they kind of show the diode right here, just tied directly to ground, kind of a single-ended thing. And if you scroll way up here, did I pass it? Yeah. And why this section and this section here are separated by this package description, I have no earthly idea. But anyway, if you read through this thing, where's my pointer? Here's my pointer. It says 3-wire, 4-wire, and it says thermocouples are configured differential with internal ground. Oh, and diodes are configured single-ended. And it kind of says that here. And it also says, so I don't know, there's just not enough information in this I know the differential measurements work. I've tested it. So I'm going to leave it wired up for differential measurements because I know it works. I'm already using the 3904 transistor and setting it, as you saw in the code, for differential measurements and not single-ended. So yeah, I don't know if this is I don't know what the reason for this note is. It doesn't say it can't. It just says it's just the way they're configured. And I don't know. Someone knows, maybe they can tell me. But for now, I'm going to keep it the way it is because I know it works. And I kind of like this drawing a little bit right there, so I'm just going to delete this guy. Whoop. And tie these guys together. And I'm just going to leave it like that. So, because to me that looks a little better. Let's go fix that other one here real quick. Well, you saw I did this one. You don't need to watch me do the other one. I'll go ahead and fix it. I'll be right back. Okay, so I went ahead and updated the drawing. So we come out of channel 20, which is our designated cold junction channel. We come down, go into the collector and the base, come out of the emitter, which goes to ground, and then ties back into the cold junction differential measurement channel. All right? And I know common's tied in right here. I should probably take this out and give it its own ground. It might look a little better. Electrically, it shouldn't make any difference, but I don't know, it doesn't matter. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.